Hi everyone. We are presenting on cowshed wastewater for direct crop irrigation. My name is Diane Castellanos. Amit Hazut is our Israeli student.
I'm Tori Klazura.
And I'm Mimi Roberto.
So the sample we received was 500 milliliters of agricultural wastewater, specifically cowshed wastewater, as you can see on the left of the slide. And due to the origin of our wastewater, it was safe for us to assume that the sample would have large amounts of organic solid matter, high nutrient load such as ammonium and phosphate, and high concentrations of salt. The intended reuse for our wastewater sample was for direct crop irrigation. This reuse requires a low amount of total suspended solids, low chemical oxygen demand, a low amount of salt, and no pathogens.
So in order to analyze our water, our team conducted multiple tests to determine the water quality. We first used meters to collect measurements of the physical parameters: pH at 6.94, total dissolved solids, the same measurement as salts, 2.49 parts per thousand, turbidity, 133 NTU, total suspended solids, 535 milligrams. We then tested for chemical parameters. Within that grouping, we had both inorganic and organics. The inorganics were the nutrients, ammonia, measured at 1.53 milligrams per liter, and phosphate, measured at 47 milligrams per liter. Both of these nutrients had to be diluted in order to be measured because there were such high loads. For inorganics, we had chemical oxygen demand at 3,590 milligrams per liter. Our last grouping was microbial, in which we tested the amount of coliforms. The amount was too high to be counted, which is to be expected when working with cowshed wastewater. As Diane brought up before, the origin of our water showed us that we needed to look out for high amounts of organic matter, high nutrient loads, and high salt concentration. By looking at the measurements we conducted, we see that we do have high dissolved solids, high turbidity, high total suspended solids, high nutrient levels, high chemical oxygen demand, and high coliforms. However, we did have a neutral pH, which is what we wanted. The rest, however, are too high parameters to be useful for direct crop irrigation. By conducting these tests for water quality, we were able to determine our treatment methods for the next lab in order to meet the requirements for recycling our wastewater for direct crop irrigation.
Based on the results of our analysis that Mimi just mentioned, and based on our intended reuse for crop irrigation, we decided that the principal contaminants that we needed to treat were organic matter and pathogens. To treat this, we started with coagulation, flocculation, and settling. We added various amounts of a coagulant, ferric chloride, to 6 wastewater samples, did fast mixing for 30 seconds, and then mixed it slowly for 15 minutes. That caused small particles and colloids to clump together as seen in the top photo. With the help of gravity, we let the matter settle for 15 minutes, as seen in the bottom photo. Then we measured the turbidity of the water, and we determined that the sample with the lowest turbidity had the best concentration of ferric chloride added. We took the sample and disinfected it with chlorine for inactivation of pathogens. We added varying concentrations of chlorine to the sample, and after 10 minutes, we put DPD into the samples to turn them different intensities of pink based on the amount of chlorine. And those can be seen in the 2 pictures of the pink samples. We then put them in a chlorine meter to measure the residual chlorine. We wanted a residual of 0.5 milligrams per liter to prevent regrowth of bacteria in conduction pipes later on. We plotted the residual chlorine against the chlorine that we added on a graph to determine that the chlorine demand needed to get our desired residual was 1.4 milligrams per liter. This can be seen on the graph to the right.
So for our applications, we wanted to find areas in which to implement the methods Tori just mentioned in both Israel and Southern California as a way to increase the use of recycled water in both societies. Seeing as farms in Israel are already required by law to treat their own wastewater, we wanted to improve the current treatments at a kibbutz in Israel called Beirut Yitzhak. which is currently sending partially treated water to a nearby water treatment plant rather than utilizing it for their crops. A similar method can be implemented in Irvine by treating wastewater from Parks Dairy and transporting water from Tanaka Farms, which is about 12 miles away.
Lastly, we would just like to thank our sponsors for making all this possible, who are Curtis and Shirley Chambers, the Mireya Gallinson San Diego Israel Initiative, and the Israel Institute. And thank you for watching our presentation.
Thank you.
Thank you.